Good morning. Today we are going to discuss our third class. In third class, first I will discuss electrostatic conduction. When two differently charged bodies or a charged body and an uncharged body are kept in contact then redistribution of charge takes place. As a result, the uncharged body gets charged while the differently charged bodies acquire charge in the ratio of their capacities. If two charged identical bodies having charges Q1 and Q2 are kept in contact, then each will acquire charge given by that means this is called conduction. When two bodies will be in contact, then redistribution of charge will take place. You will have to remember, if the two bodies are identical in shape, then their charges will be equally divided. But when two differently charged bodies comes in contact, their shape may be different. Suppose they are spherical in shape. In that case, what will happen? So I am writing here, if differently charged bodies are spherical in shape, then charge will be redistributed. In the ratio of their radii. If they are spherical in shape, differently charged bodies, spherical in shape, then their charge will be redistributed in the ratio of their radii. This is our electrostatic conduction. Now comes to the third point, it's electrostatic induction. Third point is electrostatic induction. Third point, electrostatic induction. When an uncharged body is brought near a charged body, then its near end acquire opposite charge and the far end acquires same charge, This method of temporarily charging is called electrostatic induction. So, let me explain the phenomenon actually. Suppose there is a charged body, some positive charge are there. Now I have brought an uncharged body there. This is an uncharged body. So when an uncharged body is brought near a charged body, then the near end of this uncharged body acquires opposite charge. It is plus, so it is minus, opposite charge. But the far end acquires the same charge. Now, these charges are known as inducing charges and denoted by Q0. These charges are known as induced charges and it is denoted by Q. Now you will have to know, if this charge body is removed, then charges in this uncharged body, which was uncharged previously, if this charge body is removed, these charges will also disappear. Again, if it is brought near, then charges will come here. That means it is a temporary method. If the charge body is there, there will be charges. If the charge body is removed, there will be no charge. So, relation between induced charges and inducing charges is that Q is equal to Q0 1 minus 1 by K, where Q and Q0 already you have got induced charges and inducing charges. K is equal to dielectric constant, and about this constant we will know in our next class. K is equal to dielectric constant. So we have completed the production of charges process. Now we are entering in another section. You write Coulomb's law. Next point is our Coulomb's law. It states that the attractive or repulsive force acting between two stationary point charges is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square of the distance between them. Also, the force act along the line joining their centers. So this is our Coulomb's law. Mind it, Coulomb's law states that force will act. It may be attractive, it may be repulsive. But that force will always act along the line joining the centers of the charges. And that's why Coulomb's law or electrostatic force is considered as central force. Remember it. It is called central force. Now, Coulomb's law in scalar form. Next heading, Coulomb's law in scalar form. Coulomb's law in scalar form. So, let us assume that 2 point charges Q1 and Q2, and this is distance R. So, we are writing here, let 2 point charges Q1 and Q2 be separated by a distance R. According to Coulomb's law, what you will get? Coulomb said the attractive or repulsive force is directly proportional to the product of the magnitude of the charges, and this force is also inversely proportional to the square of the distance between them. Now combining, if I combining I am getting F is proportional to Q1 Q2 by R square. F is equal to K Q1 Q2 by R square, where K is constant. So Coulomb's law, according to Coulomb's law, mathematically Coulomb's law is F is equal to K Q1 Q2 by R square. Q1 Q2 are the charges, R is the distance between them. In vacuum or in free space, K is equal to 1 by 4 pi epsilon naught. K is equal to 1 by 4 pi epsilon naught, and in SI unit its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. K is equal to 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. So we can write F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. This is Coulomb's law. And you must remember 1 by 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Have you understood? This is for today. Thank you. Good day.